Hello. In this video, we're going to be talking about logarithms. So we're going to start with a question. How many 10s do you need to multiply together to get 10,000? This is an example of a logarithm. Okay, we call the number the logarithm of 1,000 to base 10. So the actual definition for logarithm is the exponent you would raise a number, which is called the base, to in order to get a specific number. So this logarithm of 10,000 to base 10 is the exponent that you would need to raise 10 to get 10,000. The answer is 4. Now the way we would write this looks like this. We would say log, and then we put the base down here, 10, and then we put the number right here, 10,000. And to evaluate this, you would say 10 to what power gives me 10,000. Now, base 10 is actually a special logarithm called the common log. And since it's so common, we don't actually have to write the 10 there. Anytime you just see log and then the number there, you know this is base 10. So this is called the common log. Alright, so let's make it a little bit more generic now. You're always going to have the log of some base of some number. Okay, and this is always going to give you some exponent. I'm actually going to let x represent the exponent. This is what we call logarithmic form. So logarithmic form. There's another form called exponential form. Exponential form. So in order to go from logarithmic form to exponential form and back, exponential form would look like this, by the way. You would have the base to some exponent, and that would equal this number right here. In order to go back and forth in the way that I remember it is this. I think of it like I think of a lot of things. I try to think of a word that reminds me of things. And the word log, to me, reminds me of trees. So I'm going to have me a nice little tree, a little happy tree. So here's my happy little tree. Okay, and this tree has some base. Let me finish drawing the roots of my tree. So there's my happy little tree. And the happy little tree has some leaves. And on the happy little tree, there's this fruit. And this fruit is my exponents. We've got b to the x power. Okay, and that equals some number out here. I used m up here. I'm actually going to use y down here. So this is exponential form. If we want to go from exponential form to logarithmic form, we have to cut the tree down. So I'm going to cut this tree down, and it's going to fall over this equal sign. Okay, so once it falls, this fruit is not going to stay in it. It's going to drop straight down. Okay, and then the tree is no longer a tree. It is now known as a log. It's got the same base though. Okay, and then this y is just going to move over to not get hit by the tree. It's not practicing safe. You're supposed to go toward the tree if it's falling down. But it's going to try to run away, and it makes it. So we end up with something that looks like this. So just remember where everything goes, and you can easily go from exponential to logarithmic and back. In order to go back, you put the exponent back up in the tree, set the tree back up to have the base, and that's pretty much it. So let's do a couple examples. So example 1. Let's say we want to write 2 to the third, which is equal to 8, in logarithmic form. Alright, so I got to cut the tree down. The exponent falls straight down. Okay, the tree is no longer a tree, it's now a log with the same base, so log base 2. And then the 8 just moves over. And you may see it like this, or you can switch the two things and have log base 2 of 8 over here and the 3 over here. It gives you the same thing because it's equals. Alright, so there's going from exponential to logarithmic. Let's do another example now, where we go from logarithmic to exponential. So example 2, I want to write the log base 2 of 16, okay, which is equal to 2 to the what power of 16? 4, in exponential form. Alright, so I gotta take my log and I gotta set it back up. I gotta set the tree back up. So we've got 2, and then I gotta put my exponent back up in the tree. So 2 to the 4th power is equal to 16. That's it in exponential form. Pretty easy, right? Alright, now a couple things about logarithms. Yesterday we talked, or in the last video, we talked about inverses. So let's take this exponential equation and find the inverse. So we've got some base to some exponent, and that's going to be my function. So I'm going to say y is equal to a base to an exponent. To find the inverse, I switch my y's to x's and my x's to y's. So I get x equals b to the y power. And then I have to solve for y. Now before we had no way to get the y out of the exponent. But now we do. If we change this from exponential form to logarithmic form, that y is no longer going to be in the exponent. So I'm going to cut down my tree. So I've got log base b, and then the x is going to move over, and now the y is no longer in the exponent. So this lets me know that your exponential and your logarithmic equations or functions are inverses of each other. We're going to use that later on to help us solve some equations. All right. So right now let's talk a little bit more about logarithmic functions in general. So logarithmic functions. All right, so let's talk about this form a little bit more. We've got y equals the log of some number, that's the base, of some number. Now, in this, there's a couple things that b cannot be. First off, b cannot be negative. It has to be bigger than 0. It also can't be 0, okay, because that's just boring. 0 to what power is, and this number would only be 1 or 0. Okay, and also, b cannot be 1, because 1 to what power, the only number that could go there for x is 1 as well. So b can't be either one of these two things. Now, thinking about the domain and range. Remember, in order to have your inverse, you just switch the x and the y. So since the logarithmic function is an inverse of my exponential, I just switch my domain and range. Now, for your exponentials, your range was from 0 to infinity. So now my domain is from 0 to infinity. The domain of exponentials was all real numbers. So now my range for the inverse of it, which is the logs, is all real numbers. So from negative infinity, I always forget to put my negative first, to positive infinity. All right. One last thing about this, we're going to be evaluating logarithms. I'm going to talk about it a little bit more and do a couple of examples, harder examples than what I've been doing in this lesson. So when you go to evaluate a logarithm, you're just asking yourself, whatever the base is, to what number, or to what exponent, gives you whatever that other number is, that big number. So for example, if you have the log base 4 of 16, this is asking you 4 to what power gives you 16. So 4 squared is 16. So if I evaluate this, I get 2. Example 1. Okay, that one's pretty easy. Let's do one that we actually have to think about a little bit more. So for example 2, we've got log base 5 of 1. So 5 to what exponent gives me 1? So thinking about your properties of exponents. What exponent always gives you 1 no matter what the base is? Okay, anything to the 0 power gives you 1. So anytime you see a 1 here, you'll know your answer is 0. All right, for my last example, let's say we've got 7 raised to the log base 7 of 23. This one's a little trickier. You actually have to think about what logarithm is. So this is asking 7 to the what power is 23. Okay, so that's what you get when you evaluate this. You get the exponent that would give you 23 if you raise 7 to it. Then we are raising 7 to it. So this is 7 raised to the exponent that if we put 7 to it would give me 23. So my answer there is just 23. So one more time, let me try to say that a little bit clearer. We're raising 7 to the exponent that if we raise 7 to it gives us 23. So our answer is 23. All right, I hope you understand logarithms a little bit better now. We will continue next time with some more logarithmic functions, and we'll go through something that will help us find a logarithm if it's not just a nice number like this, or if we can't just use a property. Good luck. Hope you have a good one.